Hey everyone, and welcome to another video on building application integration patterns and event-driven applications with Terraform and .NET 6. This week, we're going to have a look at what happens when things go wrong with these asynchronous event-driven architectures where messages are being passed around. We need to be really careful about how we handle these errors. And to start, I'm just going to do a little demonstration of what can happen when things go wrong. So I'm here in the customer service part of my application. If you're unsure what this customer service part is, it's probably worth watching the last video on publish subscribe. But this is a service that's subscribing to events that are being published to EventBridge and passing them messages to a queue. Now, if I was to change my queue policy to stop EventBridge being able to send messages, so let's say I change my action to be something that doesn't make sense, and now I reapply this Terraform code. So if I go to my customer service and I do Terraform apply, just need to pass in my var file, actually, var file dev.tfrs, there we are. So what we're actually going to see now is what happens when what EventBridge will do as I try and publish a message to the queue that EventBridge actually isn't allowed to publish to. Okay, so that's finished applying now. So if I now go back up to the top and run my integration tests, so my product API, I go into here, into tests, and run a .NET test. This is now going to create a test product in my product database, and then all the event-driven goodness will kick in. So let's see what happens after the test runs. And it did, awesome. So we've now had a product created. So if I go off to my AWS console now, and I go and have a look at SQS, and if I look at my dev queues, so you see I've got the message in my purchase order queue, and I've got the message in my product catalog queue, but actually I've not got anything in my customer service queue, and there's nothing, there's no signals that this has happened. So if I go and have a look at EventBridge now to see if there's anything on my EventBridge, and I have a look at my rules, and I look at my rules for my application integration bus, and I can actually go and have a look in here and look at my monitoring. That's the one for the customers. So look at my monitoring. And we can see there's no signs of what's happened. So what can we do to kind of handle this and prevent this? Well, that's where dead letter queues or dead letter channels come in. And this is where we can tell any of these integrations what to do with problematic messages. So if I come back to here now and actually put my SQS policy back to how it was, so under this CloudWatch event target, this SQS target, there's configuration for dead letter config. So if we add some dead letter config, what we actually need to add in this dead letter config is the ARN for a queue. So that means we're going to need to create another queue. And the normal practice is to give that the same name and just prefix it with DLQ, and that would be our customer product DLQ service. And we can then put that AWS SQS .ARN. Awesome. So we're now saying if this integration fails, then send that message to the dead letter queue. We're also going to need to redo this SQS policy for the DLQ, and that will be our dead letter queue from up here. And if I put that in there, and then in there, and there we are. So we're now allowing EventBridge to actually send messages to our dead letter queue. So if I was to actually break that action again, so that's an invalid action, reapply my Terraform code, I come back up to the top level, back into my customer service, and run Terraform apply. And we'll now recreate, forgot my var file again. There we go. So we'll now actually see what happens. We're going to add two new resources. Okay, so that's completed now. So let's go and have a look at our queues again. So you see we've now got one additional queue. We've got our product notification queue and our product notification dead letter queue. And if we go and have a look at the rule in EventBridge and we have a look at this target now, if we go in here, if we edit that target, if we look down through here, you see we've got a dead letter queue specified, and we've got this, we've got these selection options. So if I run my .NET test again now, then, so if I come back up to my product API, to my test and my integration tests, and run that test, remember the rule we want to use has been misconfigured. So this again will fail to send to our actual queue. So if we come back to SQS now, you see we've got two messages in our purchase order queue, the one we sent earlier and the one now, and we've also got one message in our dead letter queue. Excellent. So we've now got, we're not losing sight of any messages that get failed to be delivered. Awesome. So there's another place where things can fail in our application, and that's where we have the with Lambda. So Lambda itself can obviously fail, and if you're using Lambda as a source from something like SQS, you can get into quite a nasty cycle where things start to get, Lambda tries to pick up from SQS, fails, puts it back in the queue, picks up from the queue again, fails, puts it back in the queue again. You can get into a really almost an infinite loop. So if we go and have a look at our product API now, I'm actually going to do this on the Lambda. So if we look at our module, we've got a module for creating our Lambda function. And we've also got this module for an SQS sourced Lambda function. And that's where I said if that was to fail, Lambda would put that back on the queue and then could get picked up indefinitely. So let's go and have a look at the code for this now. And where we're actually creating our Lambda function, Lambda does have a similar option for dead letter config. And we can specify the ARN just as we did. And to do that, I'm going to actually create a new AWS SQS queue. SQS queue, I can't spell. And I'm going to call that Lambda DLQ. And then what was the just the name that we need? And I'm going to call this queue, start with the environment name, and then I'm actually going to give it the same name as our function name, and then we'll put the letter Q on the end. So you see we're just going to call that, whatever the name of the Lambda function is, and dead letter Q. And then in our ARN, we're going to add AWS SQS queue .lambda DLQ .ARN. Awesome. So we're now actually added some dead letter configuration for our Lambda function. And again, we need to add the queue policy from the other page to allow the Lambda service to put messages. So if I just grab that from there, and we take our DLQ ARN, DLQ.id, here it is, and then it's going to be lambda.amazonaws.com. The resource again is our Lambda dead letter queue, and then the source this time will be our Lambda function, which is AWS Lambda function dot function dot ARN. Awesome. So we're now actually in our SQS source Lambda function saying if Lambda is to start failing, then also offload them messages to the dead letter queue so we can go and have a look at them later. And we can also actually do that at SQS, at the SQS level. So if I now go and look at my product API again and my event handling, and I look at my update product catalog Lambda. So it's this update product catalog Lambda that is actually going to be reading from our queue. But so I can also do that with my queue now. So I've got this queue for updating the product catalog, and against the queue there's a couple of options that you can set to control that delivery to Lambda. And that is actually what's called a redrive policy. So I can add a redrive policy here, and the redrive policy needs to be JSON encoded. The first option is our dead letter target ARN, so that's the target for our dead letter queue. And the second is the max receive count, and I'm going to set that to 2. And then of course we need to create another queue for our dead letter queue. So I'll just duplicate that queue that already exists, put DLQ on the end, DLQ on the end. That doesn't need a redrive policy. And then I can say AWS SQS queue dot product catalog updates queue dead letter queue, and then my ARN. So what this is saying is that if a message has been delivered more, attempted to be delivered 2 or more times, then instead of trying to deliver it again, just redirect it to our dead letter queue. So now we've got error handling in a couple more places. If our Lambda function starts to fail, we can route them messages to a dead letter queue. And also if something tries to read messages from our queue 2 or more times, it will also redirect them to our dead letter queue. And we actually had that happening already. So if we have a look at our update product catalog queue in the console now, that is already happening. You can see we've got 2 messages in flight. And these messages have been there and they're in flight, which means something's trying to process them. So Lambda must be failing with these messages because they keep going in flight and then back to available. And you can see if I refresh that now, that the messages from our update product catalog queue have actually been redirected to my dead letter queue. And that's because they will have been received more than twice by Lambda. So Lambda's just picked them. The SQS service has said these messages have been received more than twice. So let's actually just redirect them to our dead letter queue. Okay, so at all points of our integration points now, we've got some more robust error handling. Previously, messages were just going missing and disappearing without any real signs of where they went. Now that we've got dead letter queues, if there's any misconfiguration or any errors, these messages will now be routed to a dead letter queue. Now that's great, but what happens if messages get routed to the DLQ? If we had tens, maybe hundreds of queues, coming into the console and looking at this manually probably wouldn't be the easiest way to manage it. So to do that, we can actually use CloudWatch Alarms. And before we configure this in Terraform, let's just go and have a quick look at the console. So if I go into CloudWatch now in the console, alarms are a feature of CloudWatch that allow us to do things based on a metric in its simplest form. So if we go and first look at our metrics now, and we look at some of the metrics for SQS, we look at our queue metrics, and I try and find my dev queues. And if I find my customer service product notification dead letter queue, and we look at the approximate number of messages visible, you can see that actually now there's a metric say there's 1 message in my product notification queue. So I can now use that to send an alarm, to set up an alarm to say if this metric is greater than, so if the average for this metric is greater than or equal to 1, and that happens for 2 out of 3 minutes, treat missing data as good, because if there's no data, that means the queue's empty. And I can actually now use this to send a notification. I could do that through SNS, and then I could trigger maybe a Lambda function off the back of that to send a Slack notification. There's a few different things you could do, but alarms are really helpful to draw our attention to things that are going wrong in our system. So how would we set this up in Terraform? So if we go back into Terraform now, and I'm actually going to create this as a new module. So if I create a new module for SQS queue length alarm, and I'm going to create my main.tf file in there. Okay, cool. So the resource I want is an AWS CloudWatch metric alarm, and that's going to be called SQS queue length alarm. Okay, awesome. So there's a few different things we can set on this. So the first is the alarm name. So I'm going to set the alarm name to come from a variable comparison operator, which is greater than or equal to threshold. We've got our evaluation period, which we want to be what we're going to make this trigger straight away. So we've got an evaluation period of 1. What is the name of the metric we want to use? Well, the name of the metric, if we go back to CloudWatch, is the approximate number of messages visible. So I will grab that from there. We've got the namespace, which is AWS SQS. We've got the period, which is going to be 60 every minute, and we've got the statistic which we want to be average. The threshold is what we want it to be. So if there's even one message on our dead letter queue, we want to actually trigger the alarm. The final thing we need to set is our dimensions, and the dimension will be specific to the metric you're using for the alarm. So in this case, because we're using SQS, that is actually set to our queue name, and that will actually come from a variable we're going to pass into this module, in this case a variable called queue. Okay, so let's set up our variables.tf now. First got a variable called name, that will be type string, and we've also got a variable called queue, which will also be type string. Can't spell queue. Oh, sorry, that was actually alarm name, not name. So we've got our two variables set up there now. So now we've got this module ready to configure. So if we now go back to our customer service and we look at customer service.tf, we've got our dead letter queue up at the top here. So now I'm going to create my alarm for that dead letter queue. So it's going to be a module resource with a name of customer service. Let's just copy and paste that. And that's going to be our DLQ alarm. The source of this module is going to be up one level, and then modules, modules SQS queue length alarm. The alarm name is going to be pretty similar to that. Let's call that queue alarm, and then our queue is going to be this, so it'll be AWS SQS do.that.name. Okay, so we've got our alarm configured now. So if I now come back up in my console to my sample app customer services, and if I now run a Terraform init in here just to load that new module, and then we'll run Terraform apply and pass in my var file again, and this should now try and go off and create my alarm. So you see we're adding one new thing and we're one new resource, and we are adding an alarm. So if I allow that to create, that happened really quickly. So let's go back to our console now, and if I go and look at my alarms, and you see my alarm is currently showing as insufficient data. So we're saying that if the approximate number of messages visible in my dead letter queue is greater than 1 for 1 minute, and we see that it is, so this is showing as insufficient data at the minute. Once CloudWatch Alarms catches up, this will actually change to an alarmed state. So let's just give that a minute or two just to collect the data that it needs. So if I refresh that one more time now, you can see that my CloudWatch alarm is now showing as an in alarm state. Okay, so what can we actually do if with these messages in the dead letter queue? Well, if the message has got to the dead letter queue from another SQS queue, so in the instance of this update product catalog queue, we've got our dead letter queue configured here with our maximum receives of 2, and that's what actually led to these 2 messages that we have in this dead letter queue. Now if you've configured your dead letter queues in this way, if I actually go into my dead letter queue now, you see I've got this option at the top here for Start DLQ Redrive, and if I click that, what that will allow me to do is to redrive all of the messages in this dead letter queue back to the original source queue. And I can also do that to a custom queue if I want to, but in this case I want to redrive back to the source queue. I can have a look at the messages that are actually in the queue, so I can see there's 2 messages here. I can have a look at what the actual content of the messages were, so I can see it is my product created event. Now this is really useful because if I'd deployed a new version of, say, my Lambda function, and that Lambda function had a bug, all my messages got rerouted to my dead letter queue, I could then go off and fix the bug. and then come in here and really quickly kick off a DLQ redrive. So if I click that now, you see I've got, it's actually started to process, and it's really quickly processed them 2 messages back into my queue. If we come back to the list of queues now, you see I've got 2 messages in flight in my actual queue now. Awesome. So that is for messages that are using that direct SQS to dead letter queue integration. However, for messages that come via things like EventBridge, obviously I don't get this start DLQ redrive option because this message here hasn't come from another queue, it's come from EventBridge. And this requires a little bit more challenge, and this will be very specific to your application. You could obviously write a custom Lambda function, for example, to take messages off your DLQ and put them back into your other queue. You could build it into your current application logic, into a current Lambda function to check the DLQ. So there's a few different ways you can actually manage that that reprocessing of your DLQ, and like I said, that will be specific to your application. The important thing for these dead letter channels is to make sure that you configure them at your integration points. For one, you don't want to lose messages. You don't want messages that can't be sent to their destination to go missing for any reason. But also it gives you a really nice, easy way for error handling. If you think you have a large influx of messages coming through, you might end up with one message which is what we'd call a poison pill message that gets processed over and over again, and that's then taking up resources that other messages could be using. So instead what we're going to do is try to process that 1, maybe 2 times, and then just offload that to a dead letter queue, because it may be a small percentage of messages that are causing a problem. That combined with our CloudWatch Alarms, which allow us to send notifications if things building up in our dead letter queue, gives us a really powerful way to debug, observe and monitor our decoupled event-driven serverless applications. That's all for this week. As always, all this code is on GitHub. You can go and deploy this into your own AWS account right now. If you enjoyed the video, please like and subscribe using the links below. See you next week.